Hello, this is a video about finding the x-intercepts of a quadratic equation. I've included some examples. I hope they're good ones. Just as a note, x-intercepts are also sometimes known as the roots of the equation. They are also known as the solutions. So if it's said, look for the solution of this quadratic equation, we're looking for the x-intercepts. And they're also sometimes called the zeros. And hopefully that will be clear why in a minute. The first case, which we're going to call case 1, has no bx term, and I'll explain what that means more in a minute. Remember that all quadratic equations have the same standard form. We express it as y equals a times x squared plus b times x plus c, where a is the coefficient of the x squared term. Please notice that the x squared variable is not the same as this x variable. You put the same number into them if you're asked to evaluate it for x, but this one gets squared and this one doesn't, which makes them very different. And c is a constant, which means it has no variable. And we're first going to look at the case 1 problems where b equals 0, which means that this bx term isn't in it. For example, if we're looking at the equation y equals 3x squared minus 27, please notice that the value of a, the coefficient of x squared in this case, is 3. The value of c, the constant, notice there's no variable there, is negative 27. And since there is no bx term variable visible here, that means that b, the value of b, must be 0. Before solving this algebraically, let's take a look at the graph. This is from my TI Inspire calculator app, and right here we see that this is the graph of 3x squared minus 27. You can see that it's got a lowest point. Because the value 3 is a positive number, this graph opens up like a cup, which means it has a lowest or minimum value, which we call the vertex. But it also has two x-intercepts, one there and one there. These x-intercepts are also called they're also called the zeros of the equation, because at this point the value of y is 0, and at this point the value of y is 0. They're the x-intercepts because it's where they intercept the x-axis. Anywhere on the x-axis, the value of y for the coordinate is going to be 0. We start by taking the equation, the original equation, and we set it equal to 0. Setting it equal to 0 means we're assuming that the value of y is 0, like we saw on the graph on the previous page. We still have the 3x squared minus 27, and we're going to try and solve for x. Let's see what happens. We start by adding 27 to both sides, which gives us 27 equals 3x squared. Divide both sides by 3, and that leaves us with 9 equals x squared. And if x squared is 9, then to find the value of x, we would take the square root of both sides, and we're left with the idea of x equals 3. Since x equals 3 is the square root of x squared equals 9, we need to finish this by realizing that there were 2 points on the graph we looked at where the parabola crossed the x-axis. Because of the symmetry of the parabola, we could see that also x equals negative 3. This is because 3 times 3 equals 9, but please notice that negative 3 times negative 3, which is a negative times a negative, so it's a positive, also equals 9. In all of these problems that we're looking at, there are 2 answers. In this case, it's x equals 3 and x equals negative 3. In example 2, we've got a similar situation, but the numbers aren't as pretty, so we're going to have to do a little bit more work. This is a much more realistic situation. Again, looking at the graph, Here's the equation, 2x squared minus 14. We can see that, again, it has a minimum point, and it crosses at two values on the x-axis. But notice that those intercepts do not line up to nice, easy numbers. The steps are the same, though, and we're going to add 14 to both sides. Giving us 14 equals 2x squared. Dividing both sides by 2 gives us, and I'm going to switch the order of the variables here, x squared equals 7, half of 14. So we've got two answers here. X equals, well, before I do that, remember we're square rooting both sides. And so it looks like x equals the square root of 7. So x equals the square root of 7, but also x equals negative the square root of 7. Many people are not happy with leaving things in terms of square roots and want to use the calculator to find the decimal equivalents, which is perfectly okay. Looking at a page again from my calculator app, I found the square root of 7 is 2.65, rounding it off to 2 decimal places. So the answers are x equals 2.65, but also and x equals negative 2.65. That shows that there are two places on the graph where the parabola is going to cross the x-axis. In other words, two x-intercepts. Another example is going to illustrate what can go wrong sometimes. There are situations where when you do the math out, you come to a contradiction. We'll see what that looks like here. If we have 0 equals x squared plus 4, we're going to subtract 4 from both sides, giving us negative 4 equals x squared. And in trying to square root that, hopefully you're aware that you cannot square root a negative number. There are no two numbers that when you multiply them together, you're going to get negative 4. Because to get a negative number, you have to have a positive times a negative. And we're looking for a squared number, the same number multiplied by itself. Negative 4 times negative 4, or negative 2 times negative 2, rather, is positive 4, not negative 4. So this right here is a problem. What we say in this situation is that there is no solution. Looking at that on a graph, we can see that there are no places anywhere on this parabola where this parabola, which is the graph of this equation that we're looking at here, there are no places where this crosses the x-axis. So if the solutions to the equation are the x-intercepts, and there are no x-intercepts, well, there's no solution to the equation. Now we're looking at case 2. All those other problems were case 1 where there's no bx term. These are now where there's no c term or constant. And the form of all the equations is going to have y equals ax squared plus bx. No constant. Here's an example. Y equals x squared minus 3x. Looking at that on the graph, notice that again there are two x-intercepts, one of which is the origin, the point 0, 0, and the other one is over here. Remember when we had the value of b, if the value of b is negative, it moves the vertex, which is right here, the minimum point, to the right and down. Solving this looks a lot the same though, but there are very different steps. Instead of trying to bring one of the terms to the other side, we're going to use our skill of factoring, which we worked on a lot. This becomes 0 equals x times. I'm putting the x on the outside of the parentheses because I'm showing that if I were to multiply it back into the two terms in there, it would look like this. In other words, x is a factor of both x squared and negative 3x. And when I remove it, using division, I've got x squared divided by x would leave me x, and negative 3x divided by x would just leave me negative 3. That means that one of the answers has got to be 0, because 0 times anything equals 0. The other answer is a little harder to find, but not much in this case. We just need to know, what does x minus 3 equal 0 give us? Hopefully you can see that it'll be 3 minus 3, and the value will be the value of x will be 3. But looking at it a little more formally, add 3 to both sides, and we've got x equals 3. Remember, though, that there were two answers. You can't forget both answers. If you only give one of the answers, either this one or this one, you have not really answered the question. Another example is a little bit more complicated. Notice that the value of a, the coefficient of x squared, is no longer 1. So this gives us 0 equals 3x squared minus 6x. We're looking for the two values of x that make y equal 0, and we're going to place this into the factored form. Notice that 3 is a factor of both 3 and 6. So instead of just bringing out an x squared, instead of just bringing an x to the front of the parentheses, I'm actually going to divide both terms by 3x, leaving me with x minus 2 inside. Now I know that if 3x equals 0, then x equals 0, and that's one of the answers. But I should also be able to see that x minus 2 equals 0, means that I add 2 to both sides, and I get x equals 2 as the answer. So there are two answers to this, x equals 0 and x equals 2. Remember, you gotta have two answers. Another example of the same similar process, but we're going to find in this case the numbers don't work out as well, which is perfectly okay. The world has a lot more fractions and decimals in it than it does whole numbers. 0 equals 2x squared plus 7x. Unlike the last problem, 2 and 7 have no common factor. In fact, they're both primes. So when I factor this out, all I can bring out is the x. And what's left? 2x squared divided by x is 2x, and 7x divided by x is 7. So I need to find these two numbers. One of them is going to be x equals 0. The other will be 2x plus 7 equals 0. Subtract 7 from both sides, leaving us with 2x equals negative 7. Divide both sides by 2, and you've got x equals negative 3.5. A decimal answer. But that's okay. It happens all the time. We're almost done with this video. Case 3 problems are where y equals ax squared plus bx plus c has values, non-zero values, for all a, b, and c. An example of that would be y equals 2x squared equals 3x minus 11. And we could see that a equals 2, b equals 3, and c equals negative 11. But that's another story. There will be a separate video explaining how to solve the case 3 problems where we have all of those. This video is focused on case 1 and case 2, where not all 3 of the parameters are present. The next video will be on the quadratic formula, which is how we solve problems in the form ax squared plus bx plus c when we have all of them. Quadratic formula is x equals negative b over 2a plus and minus the square root of b squared minus 4ac over 2a. And that is convoluted and complicated enough to deserve its own video. The end.